I want to show you how to wire logic gate integrated chips, or ICs. Let's start out with a breadboard, because that's what we're going to use for building our circuit. A breadboard is a really useful device for connecting circuits together because it makes a lot of the connections for you. Every grouping of 5, like this, is connected together. And along the ends, all these are connected together. So if I show another image of it here, all these are connected together and all these are connected together. And every parallel column here is also connected together. So these groupings are connected and those groupings are connected. So if I go to the actual breadboard over here, you can see the groupings of 5. So if I put a wire in here and then another wire anywhere in that same column, say right here, they're electrically connected together, this wire and this wire. And similarly, if I go along the edge, along this row, and that row, this wire and this wire are connected together. Now the next thing I want to do is show you how to use integrated chips. Here's an example of what an integrated chip looks like, one that will plug into a breadboard. It's got these pins coming out, and internally it has a circuit in there. And I'm showing 2 possible ones here that we're going to be using, a hex inverter and a NAND gate. Hex means there's 6 of them here, and a quad 2-input NAND gate, quad means that there's 4 of them. So internally to this IC, we've got the circuits for building these logic gates. And the pins there are how you connect to the internal circuitry. Now both of these have a couple of features that I want to point out. Both of them have little notches there, and those notches are for orientation. They tell you where the 1 pin is. The other thing is both of these have 14 pins. They count 1 through 7 this way, and then back 8 through 14 this way. And both of them have pin 7 as the ground and pin 14 as the power to the circuit. So let's look at the actual ICs put into my breadboard. Now notice that I put them across the center here, and the reason I do that is because I don't want to short out these pins. So there's no connection across this divide here. So this row is not connected to this row here. So that means that I've separated all 14 pins out into completely separate rows. And notice that pin 7 is connected over here, and that's connected in the same row to this pin 7, which is connected right here to ground. Now both of these have the notch placed to the left, so that's a notch there, and you can feel that's the notch right there. And that means that this is pin 1 there and pin 1 here. And that means that this is pin 14 and that's pin 14, and they're both brought up to this row, and it's connected over here to the plus power. So this is plus 5 volts and this is ground. Let's build a circuit. This particular circuit is very simple, just an inverter into a NAND gate. Whenever I'm trying to build a circuit, it's really a lot easier to write down on the circuit the actual pins. So in this particular case, I'm showing the inverter pin 13 going in and pin 12 coming out, and that's using this particular inverter, pin 13 going in, pin 12 going out. I could have used any of these other pairs here, so I could have used 9 going in and 8 coming out. So the output, the 12 coming out goes into a 10 going in. So the NAND gate that I'm going to be using is the one that's the 10, 9, 8. So it's this one here. 10 and 9 are the inputs and 8 is the output. So you see those pins right there. So let's actually wire this up. Okay, so pin 13 on the inverter, this is the inverter on the left. If this is pin 14, this is pin 13. I could have put it anywhere in this row here. That's my input A. My output is 12, which is going to be right here. Again, anywhere in that row. The 12 goes into the 10 pin of the NAND. So if that's a 14, that's a 14, let's see, this is 8, 9, 10. This is 10 right here. And the 9 is here. That's my B input. So it has to come from some source that's giving an input. And then the output is from 8. So all I have to do at this point is make sure that I've got my power hooked up over here and ground, my A input there, my B input there, and then this is my C output. And that's my circuit all hooked up.